Are humans the real ancient aliens? A recent research paper suggests that terrestrial-style biology may be rare, and Earth may be among the first examples of a planet able to sustain life in the cosmos. How special are we? A recent research paper suggests that terrestrial-style biology may be rare, and Earth may be among the first examples of a planet able to sustain life in the cosmos. Even as the new kids on the block, humans are seemingly one of the precious few instances of intelligence to arise in the universe since the Big Bang did its thing. Harvard astronomer Avi Loeb and his colleagues in the UK have argued that the halcyon days for life are still to come. It's not even morning in the universe, it's pre-dawn. Biology may erupt like weeds on an untold number of worlds, but if so, the infestation will take place tens of billions of years in the future. Why's that? And what's wrong with life sprouting up today? Obviously nothing. After all, you're reading this, the distant descendant of a small collection of molecules that stumbled on a method for building nearly exact replicas of itself nearly 4 billion years ago. No scientist is yet sure if this molecular sleight of hand is just some sort of highly unlikely event. Although opinions abound, the new argument that prime time for an inhabited universe is still to come springs from astronomy, not biology. Loeb et al.'s proposition begins with the belief that life requires a few essential ingredients, a world that's amenable to easy chemistry, including liquid water, thick atmosphere, you know the drill. As best we can tell, there's no shortage of such Goldilocks orbs. There may be tens of billions of Earth-like planets in our galaxy, and that's not even counting habitable moons. An abundance of real estate is essential for this growth, yes, but so is time. Rustling up life, especially of the intelligent variety, might take billions of years. The argument is straightforward. The longer you wait, the more examples of biology you'll have. But stars like our sun can't wait too long. There's a relatively short opportunity to strut and fret. In 10 billion years, they've run through their easily accessible fuel and are headed out the door. But consider red dwarf stars, the runts of the universe. Their masses are considerably less than Sol's, which means they burn more slowly. The consequence: red dwarfs with 1/10 the mass of the sun have lifespans that are up to 1,000 times longer. All else being equal, that would give red dwarfs 1,000 times the probability of eventually using its energy to host a world with life. Clearly, it's most probable that this life would arise not when these stars are still young, which they all are now, but instead during their long adulthood. In other words, the red dwarfs are just getting started, and their biologically fecund years are still ahead.